Hey everyone, this is Mike North, and today we're going to be talking about the native web component standard and how your favorite framework or view library aligns with the same things that we'll be seeing in vanilla JavaScript web components of the future. One of the biggest challenges we have in building rich experiences for the web is that compared to what you start with as fundamental building blocks when building a desktop or mobile app, we have far less to work with in terms of the lowest level, most granular building blocks. Mobile app developers get to start with primitive UI elements like ready-made buttons, text fields that support different types of input, map components, video components. In the web world, this is about all we get to start with. And it may surprise you to know that this is a native web component in and of itself. Many browsers allow you to turn on visibility into the shadow root for things like inputs, text area, and more. The idea of native web components is that you should be able to not just have inputs and text areas that your browser ships with, but to be able to build your own vocabulary on top of this so that the HTML for your application matches much more closely with the conceptual model in your head. Looking at this markup, it's easy to see that we have a presentation that has a particular title with two slides, the first slide containing some text of different sizes, and the second one consisting of an image. More often than not, today's apps tend to look more like this. We call this div soup, and if you use something like Twitter Bootstrap, you're used to seeing a lot of this. Looking at this HTML, we really have no idea what we're looking at. We have no understanding of what this means, and so the markup itself has very little value other than defining the granular structure and constraints of the layout itself. This is hard to maintain. It's hard to distribute enhancement and troubleshooting of this kind of thing across a team, and it's just generally bad and difficult. The W3C Web Component Spec is a fancy term that describes the combination of four new technologies: HTML imports, custom elements, HTML templates, and ShadowDOM. We're going to finish off by looking at a couple of demos that progressively build up to a hamburger menu. And what you're looking at here is the complete code that's necessary for having an animated dynamic menu that swipes out from the left side of the screen. And you can see it's only 12 lines of HTML. So it's pretty exciting stuff. It's almost certainly going to be useful to know how to do this in the near future. So I'm really excited to show this to you today. So HTML imports are almost like requiring a module or bringing in an external CSS style sheet, but for HTML. Like HTML tags that bring in external resources, we get onload and error events. And because HTML can contain CSS by way of a style block or JavaScript by way of a script block, this allows us to bring in structure, style, and behavior all with one file. We're also going to see that HTML imports bring along some closure-like JavaScript characteristics, whereby scripts that are run in the HTML being imported can access the parent application doing the importing, but not the other way around. Custom elements give us this semantic HTML vocabulary that is way more useful than the div soup we're used to seeing. The custom element API also allows us to have access to well-orchestrated lifecycle of a component. So these are analogous to component lifecycle hooks in the Ember or Angular 2 or React world. Components can extend from other components, and this is very important if you consider things like accessibility, where your special type of button should bring along with it all button-like characteristics that the browser ships with by default. The hope is that custom elements will also be interoperable, meaning they'll work equally well with view libraries like React or frameworks like Ember and Angular 2. As long as we conform to the same way that base HTML components like text areas and inputs have their initial value set and how they notify consumers of their events that things have changed, as long as they adhere to the same conventions, there's no reason to expect that frameworks will have difficulty connecting to these things, just like we connect to the DOM elements that ship with the browser. The HTML template part of the web component spec gives us the power to bring HTML and leave it inert in the DOM. When we say inert, we mean that the browser will not parse or act on any of the HTML elements that are contained within this template. For example, if you have an image tag in HTML in your application, you would usually expect that as soon as the browser sees this image tag, it would begin to download the image that the source attribute is referencing. If this is present in a template, the browser will not begin to do this until it sees that HTML actually moved out of the template and copied into the DOM. This allows us to defer loading and rendering of resources that may be costly, but may be related to a particular component, and not needed until that thing is actually on the screen. Analogous concepts include Jade and Handlebars templates that sometimes use script tags that are not JavaScript in order to basically stop the browser from doing anything when it starts to see that text in the HTML document sent from your server. The last part of the puzzle is ShadowDOM, and this is the concept of a web component owning its own document root. This brings with it some powerful DOM and CSS encapsulation ideas that are just not possible, no matter what you do, with today's HTML and CSS. So we're going to dive into each one of these areas one by one, provide some simple examples for each, and as we go, we're going to tie them to analogous concepts in your favorite framework or view library. Let's begin with HTML templates. The way you use an HTML template is simply by using the template tag, as I'm showing here. You can see that this looks like HTML, but it's important to remember that the browser will not start to do certain things. Specifically, it won't download resources and start to parse this into HTML until you copy stuff out of the template and place it in the application DOM. If you use something like document.querySelector or if you use jQuery, you're also not going to be able to query into a template and to access the H3 inside this template, for example. Because HTML can contain style and behavior via JavaScript, you can see how these three things, structure, style, and behavior, can all be packaged together in a simple template, and it really allows us to create a nice envelope around all things that are related to this particular component. The way you use a template is you first grab a reference to it via document.querySelector, and then you pass the content attribute from that template into a function called document.importNode. You can see that in this case, we're going to just append whatever document.importNode returns to the body. And what this will do is it'll copy the contents of the template into the body directly, at which point this is no longer inert HTML. Here's an example of what that might look like. If there were no JavaScript here, you would see nothing in the bottom portion of the screen because this template's HTML is inert. But once we copy the contents of that template and append it to the body, you can see that this H1 tag is rendered on the screen. In terms of how your favorite frameworks handle this, many of them choose to transform templates into something else at build time. If we start with something like this and take a look at an older version of Ember's template compiler, we can see that the text is transformed into imperative instructions for assembling the DOM elements that correspond to what we had defined in the slide before. In terms of the lazy loading aspect of this, there are several features in Ember that allow us to bring in application logic and templates only when they're needed. One concept that's been released recently is this idea of lazy engines, where you can break your application up into layers, and only when a user crosses the threshold and begins to enter the next layer of the app will you download the appropriate resources, parse and evaluate them, and then use those JavaScript modules to render something on the screen. Angular and React both have adopted Webpack as their official build tool, and Webpack has a feature called chunking that lets you do something similar, breaking your application up into sections so that you don't have to bear the burden of sending your entire single-page app to your user just because they've started to view a particular page. Let's jump into the second piece of the W3C web component spec and look into ShadowDOM. The concept behind ShadowDOM is that each component has its own shadow root, a private document fragment that can contain its own CSS and its own HTML elements and its own JavaScript. The important feature here is that we get encapsulation, where CSS rules from the outside don't necessarily, and by default they do not, penetrate into the ShadowDOM. Here's a simple example of the ramifications of ShadowDOM on CSS. You can see here that on line 7 I have a paragraph tag that's in the application DOM, and then on line 6 I have a div with a particular ID. You can't see the JavaScript, but what we're essentially doing is we're grabbing the contents of the template that's defined starting on line 1, and then we're creating a shadow root inside the div on line 6 and copying the contents of that template into that shadow root. The end result is that we can see that this paragraph tag styling rule that we have in our CSS area, that only affects the paragraph tag on line 7. It does not pierce the shadow root getting into the shadow DOM of the HTML that is inside the shadow root of that div on line 6. By default, CSS rules do not pierce shadow roots. CSS defined inside the shadow root only affects that shadow DOM. The exception being that inside the shadow root, you can use the host pseudo-selector to style the component's boundary element. The boundary element is it's the owner of the shadow root, and it is also visible from the application world. So that is something that can be styled both from the inside and from the outside. From the outside world, you can use the : shadow pseudo-selector to explicitly pierce a shadow root. If you look into more information on this topic, you may see a reference to another pseudo-selector, which is /deep/. This was an idea for piercing all shadow roots. That is to say, even components inside other components would be affected by the deep pseudo-selector. This has been deprecated, and we don't expect this to be part of the official standard. So how do frameworks handle this aspect of the ShadowDOM, the CSS encapsulation? There are a variety of options, but they all are built upon the idea of generating somewhat randomized CSS class names at build time. This reduces the chance that one component's CSS rules will collide with another's, but it still leaves open the possibility that application level CSS rules can unintentionally affect things that are the internal business of a particular component. I'm really excited about the CSS encapsulation features that come along with ShadowDOM, because right now it's easy for things to get out of control and to become very difficult to maintain. Essentially, it's almost like we're programming with globals. Another important aspect of Shadowroot is this concept of content projection, whereby things that are specified on the boundary in the application world, the values make their way into the component's internal world. So here's one example of content projection, whereby this attribute we're passing into this input by way of the placeholder attribute, that makes its way into this second div, the placeholder div. So the way that this particular type of encapsulation works is no mystery. Essentially, the initial value is passed in by way of the attribute, and then any other values have to be set explicitly using the JavaScript API for this input element. Here's another type of content projection, and this is useful in thinking about components that have an open and a closed tag, like a text area. Here we can see that the contents of the text area are placed in a particular spot inside the ShadowDOM. So we're going to look at an example of how we can use some new content projection ideas that might be useful for maybe a particular type of text area. In this example, we're going to again grab the div defined on line 7 and create a shadow root and then paste the template that's defined on line 1. Essentially copy the contents of that template into that newly created shadow root. If you want to think about this in terms of a jQuery plugin, the kind that used to consume a chunk of HTML and replace it with something completely different, that's not totally wrong. The important difference here is that the HTML, the source HTML, is not consumed. In fact, it still exists in the application world. It's just not as closely related to what's shown to you on the screen as as you get from like the contents of the template. So here, what's happening is that if we look at line 2, there's a content tag, and you may not have seen this before. This select attribute on the content tag essentially tells us that within the body of the component that we're upgrading, and the body is represented in this case on lines 8 and 9, right? That's the contents of this div that we're upgrading into our custom component. Within that body, we're going to find anything that matches this selector, where you have a class h1. And this content tag on line 2, it's almost going to be, you can think of it as if we're replacing that with whatever we find as a result of querying with that selector. And you can see here we will end up finding this span containing the word good, which is on line 8. And so the reason you're seeing the word good large in the rendered HTML is because that actually ends up being inside the h1 tag that's defined on line 2. Just for fun, I added a static paragraph tag on line 3 so we can see the order that things are placed here. And then on line 4, you can see we have a content tag with no select attribute. Essentially what this does is anything that hasn't been plucked out by way of a specific content tag with a select attribute, anything that's left is going to be dumped on line 4. And that's why we see hello world. That in the rendered HTML is below the static paragraph tag, that we have defined on line 3, and that is below the h1 tag. One thing I want you to notice is the way CSS affects this. So if we look at the CSS, it's saying all paragraph tags inside ID of good host, though they should be colored blue, and you can see that the stuff we're passing into this component is sort of the inner HTML of the component. That still lives in the application DOM world. that ends up being styled by application level CSS. But the paragraph tag we have defined on line 3, that is private. That is inside the component's shadow root, and that is unaffected by this CSS rule. The way this concept of content projection is handled in your favorite frameworks is in Ember. We use yield, and this is essentially taking the inner HTML of a component and placing it in a particular spot in the component's private structure. Angular 2 has this concept of ng content. Angular 1 has ng transclude. And in the React world, this.props.children will give you child components of a particular component. HTML imports are the third part of the W3C web component spec. And this one's pretty easy. It almost looks like the same way we would bring an external style sheet into an HTML file. The way we access the contents of this HTML import is first querying for the link tag itself, and then accessing the .import property on it. And this will give us a document fragment. For JavaScript that exists inside the HTML being imported, you have access to the parent document, but the parent document cannot get access to the child document itself. Although it is possible to establish a two-way method of accessing things just by establishing a child from the child reaching up to the parent and maybe passing a callback or something like that. But you see that from within the imported HTML, we can write document.currentScript.ownerDocument, and that gives us the application document. So we could query selector for a particular thing from the thing being imported, but we'd be querying in the host, in the importer's, document object. So in terms of importing components and importing things, major frameworks typically use ES6 modules and import things in the way you've probably seen before. The last piece of the puzzle is this concept of custom elements. I look at custom elements as being the thing that brings all four of these concepts together. It's particularly important because it's what gives us these composable named building blocks with well-orchestrated lifecycle hooks. They allow us to extend existing HTML elements, and this is the most important piece of the puzzle in terms of aligning the way your HTML looks to your mental model instead of aligning your HTML to the particulars of the way you want your layout to look. So let's build a simple custom element just to illustrate how all of this fits together. The first thing you end up doing is you end up creating a prototype for a new type of element. And in this case, we're going to extend the base button element, and we're going to create something called a mega button. So we clone the HTML button elements prototype, and then we're going to call document.registerElement, and the first argument we'll pass in is a string that will determine the tag name that we can use in our HTML, upon registering this. In the configuration object that's passed as the second argument to register element, we're going to pass the prototype that we just created above, and then we're also going to say that this extends on top of the HTML tag button. The next logical step after you create and after you register your element is to add a template to it. And the way you typically do this is grabbing a reference to your template, and then in this created callback, you're going to create a shadow root, and then you're going to append to this shadow root the contents of the template. And so now you can start to see that at least 3 of the 4 concepts are really coming together now, where we've got a shadow root, we've got an HTML template, and we're bringing them together in the context of a custom element to create something that's got a structure in alignment with the template. So this is starting to look much more like an Ember or a React component. No surprise how frameworks handle this. They all have their own representation of components. So I'd like to finish up by going through a quick demo. We're going to look at a hamburger menu, and I hope to show you how we can start ugly and progressively start cleaning things up, eventually ending up with a really nice semantic way of creating a hamburger menu that involves a lot less complexity at the application level than we would have to deal with were we to, not use components. What we have here is a hamburger menu. I'm sure you've seen one of these before. The idea here is to have a menu title and then any number of menu items inside. You can see here we have sort of the non-web component div-based approach. And just looking at it at a glance, it's not immediately evident how all of this ends up being structured and styled such that it's the menu you're seeing in the rendered area of the screen. The complexity of the style here is it's not trivial. You can see it's about over 90 lines of less, which corresponds to a lot more CSS. There's a lot of math and a couple variables here, so some complexity there that would be nice to encapsulate. And in the JavaScript world, it's not too bad. We've got 18 lines of code. Essentially, we've got a function that handles a button click event, and then when the window loads, we're going to add an event listener to that hamburger button, so that our button click listener function is called when this click event is fired from the button. So it should be pretty straightforward. So if we look at if we componentize this, right, and essentially we want to be able to use this markup here. This is the next evolution of the example. This nice semantic markup is much easier to read, and we can see that the menu comes out just as it did in the previous example, and we can alter an attribute here, and we should see the title of the menu with a little lag there. It's updated accordingly. So how is all this working? Well, in short, it's a lot more JavaScript, and it's frankly because we're doing a lot more. So you can see that each of our two components has its own respective template, and within the template we've got the style that applies to that particular component, and a lot of private DOM, and here we've got our content tag for content projection. So you can see here that we have to grab our two templates, and then we have to register each of our two elements. So there's registering our hamburger menu element and our hamburger menu item element. The hamburger menu item is not all that complicated. We just have to grab the content of this template and use our document.import node function to grab that document root. Then we create a shadow root within this component and append the contents of the template to that shadow root. Here we're just setting an attribute of the resultant component's outer wrapper, which extends from the link tag, to match the attribute passed in. So essentially it will behave like a link, and it will pass through this href attribute, and it will behave in a link-like way, linking to the same thing. You can see here we're doing the same thing with a caption. We're getting the attribute from the body element, and then we're setting the attribute inside our root element. In the component's shadow world, we're setting the inner HTML property of this hamburger menu item caption template. And we can look at where that is over here. That is this right here. So we're making sure that the caption gets rendered properly. So it's passed in here, and it ends up being placed right there. So this is a different type of content projection where we're taking an attribute and placing it somewhere explicitly. So it's quite complicated. Our JavaScript has grown, but if we wrap all of this together and use the last piece of the puzzle, the HTML import, essentially we can contain all of that encapsulation in an HTML file, and we're left with almost no CSS, no JavaScript at all at the application level, and we can use the same exact markup and get a nice hamburger menu that's animated and use these custom components just as we were in the previous two examples. So in the future, this may be something that you use in combination with React, Ember, or Angular 2. W3C Web Components, folks. Check them out.